Hi, everyone. Hello. Thank you for joining us. We hope everyone's having a great day at Dash today. We want to thank Datadog for organizing this great conference, and also thank you all for joining us this afternoon.
My name is Tiffany, and as introduced, I lead the shared services team at Airbnb. Our team's responsible for the common components that help developers build and operate services at Airbnb. And we've been focused a lot about the common services that enabled our move to SOA. So I'm really excited to be here today to share our experiences.
And my name is Willie. I'm the engineering manager for the observability team at Airbnb. My team's mission is to make sure that our engineers have the monitoring and introspection tools to effectively develop and operate their services. Our talk is divided roughly into 3 sections. I'll cover largely the high levels, setting up the context leading up to our SOA effort, and closing the talk by generalizing our learnings based on our observations on the industry.
I'll be walking us through the 2 SOA attempts that Airbnb did, and sharing a lot about both the successes and the learnings that we had from the experience. Now, take it away, Willie.
Thank you. OK. SOA stands for Service-Oriented Architecture. It's a concept that's been around for at least 25 years. How many of you have been a part of an effort to break apart a monolith into a service-oriented architecture? Good, many of you. Just to make sure that we're on the same page, we're going to define SOA quite broadly for this talk as a software development model in which you divide up your stack into any number of distributed services rather than a single monolithic application. While preparing for this talk, we noticed that most existing talks and literature on the topic tend to focus on how to do SOA the right way. At Airbnb, we discovered that it was actually rather difficult for us to apply those learnings because most of our challenges ended up being organizational in nature. So we took inspiration from this observation and decided to make organizational challenges the theme of this talk. We will share the motivation, the challenges, and sort of some of the strategies that we use to overcome those challenges at 1,000 engineer scale, including a look at our first failed attempt at SOA. Founded in 2008, Airbnb is a global travel community that offers magical end-to-end trips, including the places that you stay, the people that you meet, and the things that you do. This is the earliest screenshot that I could find of our website from 2008. We come a long way since this simple web page. The next year, we added key features like search, maps, and the listing details page. And all of these remain core to our product today. In 2014, we underwent a major rebrand to redefine how we saw ourselves as. For engineering, though, this was a major project involving over half of our team, redesigning every aspect of the website. It had to be executed without any asset leaks and launched seamlessly with the click of a button. In 2016, we launched our most ambitious project yet, Airbnb Experiences. This features unique activities designed and led by inspiring local hosts. We built it to create an opportunity for anyone to share their hobbies, skills, or experiences, not just people with places to share. More recently, we built Airbnb Plus and Airbnb Collections. Airbnb Plus features beautiful homes from exceptional superhosts around the world, and Airbnb Collections help business, family, and really any traveler find a special home just for them. During my 5 years at Airbnb, there was a major product launch once every 5 months, which is a lot to ask of a relatively young engineering team. Such a high velocity of product development presented an incredible challenge for our engineering team. Like most startups in seek a product market fit, Airbnb started off as a monolith. Unlike an SOA, a monolithic code base is a single tier of application that services all of your needs. For early Airbnb, this included functionality like search, payment systems, and fraud prevention, all in the same code base. There are actually many benefits to a monolith. Because they're simpler, they're easier to build, develop, monitor, deploy, you name it. And building new features generally require lower overhead, and it's easier to onboard new hires. We chose Ruby on Rails as our first original framework, and so we affectionately call our monolith Monorail. And with this choice, our founder, Nate, was able to iterate quickly to achieve early traction and get Airbnb off the ground. But as many of you already know, monoliths don't scale without significant investment. When you have a lot of engineers working on a single code base, a lot of contention starts to arise. One problem that we ran into early was that we had so many engineers committing to the same code base, and there's so much comments on our PRs that we're simply overwhelming our code repository. Another early issue that we ran into was that things like unit testing, build, integration testing started to take longer and longer to complete. These build steps tend to scale proportionally to the number of engineers. And so you have to trade off product productivity and cost. There are much harder scaling challenges, though, to a monolith than unstable repository and slowing build times. As Airbnb's engineering grew over 100 engineers, we noticed that we were starting to experience increasingly more frequent backlogs in our monorail deploy chain. On a busy freeway, traffic accidents can quickly cause the entire freeway to suddenly back up. And it takes time for the emergency responders to arrive. In the meantime, you're stuck in your car, getting nowhere. Bad changes in a monolith is just like an accident on a busy freeway. Backups occur very easily because too many engineers are waiting to make this change at the same time. Excuse me. Then there's the issue of code ownership. When an entire company works on one code base, it can be difficult to clearly delineate who's ultimately responsible for a given code. Some code goes entirely unowned. Well, I'm sure you've all seen other code have too many engineers developing on it at the same time. Ambiguous code ownership can lend to much bigger problems. Most significantly, important engineering concerns like performance, code quality, and scalability become difficult to have accountability for. So for us, these are the most significant challenges with our monorail: deploy contention and unclear code ownership. And by 2012, these limitations were beginning to hinder our productivity in noticeable ways. As it so happens, also in 2012, it was the year when we first started to build services outside of monorail for the first time. Our very first service was a search engine that helped us more quickly respond to user queries based on date and destination. Sorry. Next, we built, sorry, my notes are not lining up. Around the same time, we started building a pricing service. So we can run machine learning models to perform smart pricing based on location of listing and seasonality concerns. In late 2012, we started building a fraud prediction service for running early supervised learning to help us catch bad actors on the website. What do these three services have in common? There are many correct answers, but the one I was looking for is that these services tend to be CPU bound with low latency requirements, which make them ill-suited for the Ruby programming language. What we then observed was that the few teams who had their own services were able to deploy on their own timeline whenever they chose. Monorail deploy contention simply didn't apply to them. And if they did make a mistake, it was also more clear who should be responsible for owning that mistake. This gave service developers a strong sense of ownership and control over their own services. And best of all, they did not experience the traffic jam that monorail developers had. And for the rest of us, this is what we saw. And we all wanted to be that guy. And thus began our journey into a service-oriented architecture. And I'll now hand it over to Tiffany to tell you more about it.
Thanks, Willie. So, SOA attempt number 1. Our goal: power the first endpoint in Airbnb entirely through services. So we started building out services, and what we realized was that we were missing the frameworks and tooling to really support service development. So one of the first things we started investing in instead was a robust HTTP client. What we observed was that as more function calls were translated into service calls, once the service kind of went bad, this could easily cascade upstream and affect all the other clients. And so by rolling out this robust HTTP client, we're able to introduce circuit breaking behavior and kind of like improve this resiliency in our infrastructure. What we also noticed, though, that by standardizing around a single client, we not only solved this problem for existing service calls, but any new service and any new service pair client that came online. And this gave us a taste of like the high leverage that frameworks could have when you kind of roll it out through your infrastructure. Based on this success, we invested in an automated service discovery framework. It's been open source, and you may know it as SmartStack. And what this was trying to solve was that as we moved from managing a single monolithic app and a single pool of resources, we were managing multiple services, multiple resources. We had to kind of grow them out over time, replace instances, and we wanted a very low touch, but again, resilient way of managing this. And so SmartStack provided like a transparent way of doing service registration, deregistration, health checking of services, and load balancing client traffic. With all this investment, it seemed like things were going well. We're starting to build more and more services. But unfortunately, we'd underestimated the challenge of migrating that endpoint to services. The SOA attempt was behind schedule. It missed several deadlines. And a year into the effort, we called it off. What had happened? With sufficient time, with sufficient resources, all of the problems I shared could have been solved. But really, we hadn't approached the project the right way. We'd gone for a bottoms-up approach, and we should have got everybody on board in the first place. As a result, we had a strong case for why Airbnb had to make this transition to services at this point in time. And we kind of remain in the monolith. What about the contention that Willie kind of shared? Well, we found that just by investing in deploy and build pipelines, we were able to kind of overcome that productivity hurdle. We share a lot of what we've did in a talk called Democratic Deploys at Airbnb. But essentially, what we'd kind of learned was that it was more convenient to work in a monolith than it was to work in services. Now, in fact, the two investments we made actually meant that even though there wasn't an effort to move to an SOA, developers were still building services. And what they realized from building and operating these services that there was quite a lot of cost involved. Cost that just didn't exist because there was already a monolith and you could make changes there. And so we remained in a monolith for a while. But spoiler alert, we had 2 attempts to move to an SOA. So what happened? What changed between 2012 and 2016? A large part of that is we grew. Year over year, our engineering team doubled in size. And what we found with this growing team size was that the problems of the monolith had become magnified. We were now spending 15 hours every week stuck in that traffic jam. And with many more engineers on the team, more people were frustrated by this experience. 5% of all changes to the monolith took upwards of an hour, close to 2 hours to deploy to production. And worst of all, in spite of all our efforts invested into further tooling and improvements to the build and deploy systems, we kind of plateaued at 200 commits merged per day. And for an organization rapidly approaching 1,000 engineers, that was just not acceptable. Another problem that kind of increased over time was the problem of unclear ownership in the monolith. And now for a single endpoint, it wasn't really clear how many teams would be involved and how you get that change rolling. And so that became to be a serious problem for our company. There were many efforts that took a look at this and tried to refactor this for clear ownership boundaries. But really, we were concerned that over time, we would just regress. What was stopping us? How could we find a trusted framework to ensure that changes in the monolith had clear ownership forever and ever? Ultimately, we weren't able to land on one, and such refactoring efforts failed. And so now we had a serious problem. We could no longer rely on tooling to improve deploys, and it wasn't a clear solution for this mixed, unclear ownership in the monolith. That's how we decided it was time to move to an SOA again. Now, it really did feel like we were attempting to scale an impossible mountain. How do you convince an entire company to change the way they do product development, to move from a monolith into services? And if you think about it, we'd failed once before. And in fact, over the years, the problem had gotten bigger. There was much more code in a monolith. There were many more engineers involved, many more teams and products being affected. And so we kind of have to look back, really examine why the first attempt failed, and incorporated 3 strategies in our second attempt to make sure that it goes better this time. The first of which was to develop a template for success. Now, the first SOA attempt wasn't really clear about what they were trying to achieve. They didn't have like a clear set of deliverables, and ultimately they weren't able to prove that by moving to services, product development would increase or they would solve the problem of code ownership. And so for us, as we started the second SOA attempt, what we realized was we couldn't just pick any endpoint in the product flow. We needed an endpoint that was both critical to the business and of reasonable complexity that would really kind of like prove that SOA could work for any flow in the site. And so we decided to pick the listing detail page. And what is this page? This is the page you see when you click into any search result on Airbnb. And for many guests searching for a night to stay, you go through multiple of these listings before you land on that perfect listing. And as you can imagine, it's both critical for our business and under frequent product development. So a quick poll for the audience. How many teams would you have to work with to commit a change to this page? Any takers? All right. One? I can have another one? That's too low. You over there, do you have a number in mind? 8. 16 at last count. So you can imagine making a change to this page was a quick way to fill up your calendar with lots of meetings. To have a sense of the complexity, imagine from this product page, each box is a component, each component is owned by multiple teams. So you can see that it's really difficult to get changes here. And when things went wrong, you had to kind of like figure out what went wrong here. And if we could prove that this page could be powered entirely by services, this would definitely be a model for any other page moving to an SOA. And so with a target in mind, we assembled a team of engineers from product and infrastructure to kind of tackle this problem together. So first of all, what was in the monorail? Let's imagine this is monorail, and it's powering the listing page for both web and native. And what we realized was monorail was doing multiple things. So first of all, it served as our API layer. It was also rendering like a lot of web traffic. And finally, there was this big block called business logic, whatever you use to power this page. And so the product teams took a look at it, and they were able to kind of clarify like which pieces belong to which product and which team. And really did a good job here. What they also quickly realized was across these different product pieces, there were a lot of shared components. So for example, common data models, like the user, the listing. There were also a lot of horizontal concerns, like authentication and translations. And all of those needed to be accessible out of the monolith in services. So the next step for product and infrastructure engineers was to move all this logic out into services. And by doing so, we basically enabled the next step, which is to move the product logic into services. But before we did that, we wanted to make sure that by doing so, we could still maintain that consistent API as we moved out of the monolith into services. So we invested also in an API framework. And at this point, what was the monolith doing? It was just our API layer, but it was also rendering web. And so again, the teams worked together. We refactored the web rendering controllers to use the same API layer, so mobile and web behave more alike. And then finally, with that refactor, we were able to separate out a clean common API tier, as well as server-side rendering for web. So as you can tell, this tight collaboration between product and infrastructure was essential to really streamline the migration and identify the critical components needed to move to SOA. As a result, we're powering the first endpoints entirely through this infrastructure today. And we've even written a guide for other product flows to follow in our example. What's next? So we have a template, prove it worked for any other product flow. We were done. We had to go from one product flow to all flows in SOA. And to do so, our second strategy was to launch SOA as a product. So as you all know, and as we've shared, Airbnb launches products really frequently. We're able to do so because we mobilize this entire company around the product launch and really meet that launch date. But this would be a risk for SOA migration because resources could be pulled off to prioritize the next product launch. So we decided that SOA should also be a launch, like everything else. And we realized that the first thing we had to do was to get alignment, based on our learnings from the first SOA attempt. SOA isn't just an engineering specification. It really meant for us a new way of doing product development. And so we needed to get all the product stakeholders on board. This would include product, engineering, design, data science. We all needed to understand why we had to move to SOA, and how it would help the business. And so we had to go on roadshows. So starting from the first flow in the homes product, we worked with the homes product teams and got commitment to move all of homes product flows to SOA. And then talking to all the enabling organizations across Airbnb, customer support products, trust, and payments, they were also committed to moving to services. And then establishing headcount and resourcing across all the remaining products at Airbnb. So that's great. We've got everybody committing engineers and to this migration. We also needed a launch date. And this was important because even though everyone was committed to the importance of SOA, it kind of felt like it was far off. Like, you could wait on it, right? Like, you could wait one more launch. I could still stay in a monolith. And so by setting and committing to a launch date, we kind of concretized it. It was something real, and it was happening, and you had to do it now. And so our commitment was to freeze feature development in the monolith in 2019. So that's great. It sounds like we've really got this going. We've got this momentum. Everyone's invested. We're on board. The third strategy, we observed that we wanted to make sure that the SOA migration went smoothly. And especially given that we've been used to monolith development, we had to onboard the entire engineering org to a new way of doing things. And so we decided it was really important to invest in tools, frameworks, and standards for service development. If you think back to what I shared from the first SOA attempt, even though it didn't work out, we had really critical infrastructure investments like the robust client, as well as automated service discovery that helped us accelerate the move to SOA, even though we didn't have a dedicated effort. And so we also wanted to compete against the perception that working in a monolith was more productive. What was this overhead that people were observing? So 2 numbers. 1, it would take someone many weeks to launch their service in production. And secondly, once you launch that service, you find yourself spending almost 24% of your changes to that service would be kind of boilerplate. And this wasn't something that would kind of exist in monolith development. So to solve the first problem, to speed up the time to create a new service, we invested in a service configuration framework. What were we spending all that time doing? So I know you can't see this, but this is like a flow chart of you wanting to make a service and you getting a service after 2 or 3 weeks. And basically, the process was you would commit code in one repository, set up your alerts in another, and then configure your service in another. There were different deploy processes. At some point, you had to talk to security for a cert, and then talk to SRE for an IAM role. What is an IAM role? And so for many product teams, this just felt like a lot of overhead just to get to the point where they're writing their first line of logic in their code, in their service. And our vision there was everything about a service should be managed in one place. And there just needs to be one process to deploy it. And so with the service configuration framework, we simplified and streamlined this process. And so all of the configuration for your service lives with the code for your service. And the way you deploy those changes to production is the same way you deploy any code change to production. I wouldn't be surprised if we have more talks about this, but this is all I can share for now. The second, we realized that we could solve both the problem of needing to do so much boilerplate in services, as well as ensuring that the quality of services coming online were consistent and met a very high quality bar. And so we invested in a service framework. Now, stepping aside a bit, what is service boilerplate? So let's say I have a service and I've set it up within a day with the new service configuration framework, and I've written a piece of logic. I'm so excited to get this to production. Well, it's a service, so I need to add an endpoint for it. And with an endpoint, I also need to set up the clients, one for each of the standard service stacks. And this kind of means I'm done, right? Well, no, because it runs a production. So you need to add metrics, you need to add error handling, data validation, all of this good stuff. And that's not it. Don't forget, you have to add dashboards, alerts. You have to maybe write a runbook so whoever gets paid about this service knows what to do with it. And we found that we were doing this over and over for every single service. And if you changed any one part in your endpoint, you have to change your client, a lot of cascading changes. Very repetitive. What if instead you could just focus on defining the interfaces for your service, let's say in a strongly typed interface description language, define your request response models, and have the service framework take care of everything else for you. We share a lot more about this in a blog post called Building Services at Airbnb. We link to all of these things at the end of our slide. So now with all of these things, I'd like to share again like the 3 strategies we did. 1, develop a template for success. 2, launch SOA as a product. And 3, invest in tools, frameworks, and standards for service development. I'd like to hand it over to Willie now to talk a bit about where we are in the move to SOA.
Thank you, Tiffany. So how far has Airbnb gone in our journey to a service-oriented architecture? So this is just a quick slide to kind of put the strategies and milestones that Tiffany outlined into a bit more of a timeline. Late 2016 was when we started becoming clear that significant refactor was necessary for our code base because we were exhausting incremental gains and tooling investments. During this time, we as an organization were starting to really internalize many of the challenges that we faced in our first SOA attempt. We also used this time to realign on the conclusion that SOA remained the best approach forward in order to prevent future refactors of this scale. By 2017, we got the dedicated staffing and buying that we needed. And on top of that, some of our early framework investments started to pay off. Earlier this year, we successfully migrated our most complex web page out of monorail. And since then, we've also migrated our search page out as well. In terms of results, we've seen some good progress. As you may recall, our main motivation for going into service-oriented architecture was developer productivity and code ownership. So this is a screenshot I took directly from an internal presentation. Based on this study, shipping a change in monorail took on average 15 minutes for this particular team. Sorry, 115 minutes for this particular team. So where does that 115 minutes go? Well, most of it was actually the amortized time across when a bad change does go out and figuring out who that change kind of belongs to. And when the same logic was moved into a service, we were able to drop that time to a mere 4 minutes. For those of you who were able to make it to Liz and Christina's talk, Google Talk on SOOs, you may be familiar with this. So for ownership, we've begun setting clear service level objectives, or SOOs, for error rates and latency across service endpoints. What you're looking at is a screenshot of our internal SOO dashboard. These efforts have only been possible because of the clear service interfaces that have been defined by our SOA. Finally, we've done a better job on code quality as well. When our product details page was in monorail, on average, 3 out of every 10 bugs filed against that page would go out of SLA. Since migrating to a service, we've been able to maintain 100% of those bugs being fixed within SLA. A service-oriented architecture is not without its flaws and costs. Distributed systems are more complex, so by nature, they're harder to monitor and harder to coordinate. But in terms of the objectives that we outlined for SOA, the project has been really successful. To close this talk, we want to reflect a little bit on sort of what changed between our first attempt and our second attempt. And to do that, I'll start with a familiar concept. Show of hands, how many of you have technical debt in your code? Every hand should be up right now, because if you don't have technical debt, you're probably not prioritizing enough. Our monorail scaling challenges essentially came down to the trade-off between infrastructure investments for tomorrow and product development today. And our monolith represented the technical debt that we had taken on over the years, pursuing ever faster product development. This is normal. Product market fit is critical. And so many startups focus on the product and band-aid their infrastructure together. This is true for even tech giants like Amazon. This is an excerpt from the book, The Everything Store. Amazon's original system was built under battle conditions, and their CEO refused to lift the foot off the pedal. He wanted to put all of its engineers on building new products rather than rewriting the same code. This is a familiar story of engineers wanting to slow down to invest in infrastructure, while business needs continue to push for everyone to develop ever more ambitious product launches. And it's no different from the story of our first SOA attempt. At some point, though, you hit an infrastructure inflection point, and that equation starts to flip. LinkedIn hit this inflection point in the year following their IPO. This quote is from an article that we found during our research. It's called The Code Freeze That Saved LinkedIn. While we have no particular insight into LinkedIn, this is likely a fairly familiar story. After years of optimizing for feature development, LinkedIn codebase had incurred enough technical debt that an overhaul of the architecture was necessary. Each new feature and each additional hire adds just a little bit complexity to your system and to your organization. At some point, you can no longer push back a necessary refactor or infrastructure investment because the long-term success of your business compels you to act now. Precisely when you hit this inflection point, though, can be a matter of great debate. And it was something we debated for basically 5 years at Airbnb. We believe that the timing of this inflection point relative to a company's evolution has a lot to do with the business environment that you compete in. For Google, it was very early. To increase search quality, they had to index more data using better algorithms than their competitors. And to do that, they needed to run better algorithms. To do that, you're largely bounded by scale and cost. So Google had to invest in a scalable and efficient infrastructure earlier than most tech companies. For Facebook, it became a little bit later when they just went beyond colleges. Other social networks of that era had struggled because they didn't scale to reach the critical network effects that were necessary for this product. And for both of these advertising giants, uptime is critical. Downtime and bugs mean poor engagement, and engagement is the key to an advertising business. Airbnb is not an ad-driven business. We're a community-driven business with unique properties dictated largely by consumers' travel patterns. In practice, this means our infrastructure handles a comparatively low throughput, but each of those interactions that you have with Airbnb generally has a higher transaction value. So as a result, developing new features and product is really core to our competitiveness. What we found is that the real push for infrastructure for us is developer productivity. So this, if I could have one takeaway for you, it would probably be this slide. There's a tendency for infrastructure investments to devolve to the lowest denominator that the business model demands to stay competitive. And all the learnings that we presented today are essentially corollaries to this thesis. In 2012, our SOA attempt failed because we as an organization was not able to translate the investment into business needs. Part of it was that we haven't yet learned this lesson yet. The other part was that the business imperative was, frankly, a little bit weaker in 2012. So we would like to leave you with this. Take a moment and think about the struggling engineering efforts, projects, or even entire organizations that you're working with. What are the macro environments? Does your business model really demand that investment to be competitive? And if you truly believe that it does, don't make technology the focus of your presentation. Focus on the business requirements and risk factors. Take it upon yourself to help your leaders understand why this is the right investment for your company. Thank you very much.